Okay, this next video is about using Pythagoras theorem. Now this is something that's most likely going to come up in a calculator paper, although we could use it in a non-calculator assessment just with slightly simplified numbers. Pythagoras theorem obviously is included in your formula sheet, but we should know that if we have a right angled triangle, excuse me, the pen's decided to stop working. Let me just fix that. Where was I? If we have a right angled triangle with three sides, A, B and C, then A squared plus B squared is equal to C squared. So we're going to then use that to solve a problem or two, sorry, whatever tech problem was happening with the pen fixed. So here we have our first question. In the example booklet we had, it talks about the local Scotland Rugby Supporters Club have ordered a new flag, and it asks us to work out the length of one of the diagonals, one of the diagonal lines on the flag. Generally, if you see a problem like this, you're going to be involved in making a right angled triangle. Wait a second, I was expecting that to give me a nice neat straight line. From here to here, just like that. So it's going to then make us, if I sketch it roughly off to the side, it's going to make for us a right angled triangle with three dimensions of 170 here, of 80 here, and let's call that x because we don't know what that is. So if we use Pythagoras, that would tell us that x squared is equal to 80 squared plus 170 squared. Remember, we're trying to find the hypotenuse, we're trying to find the longest side, so we are adding. So what we want to do is we want to work out what x squared is equal to. So we take our trusty calculator, so 80 squared plus 170 squared. If you've got a scientific calculator, you just put this in all at once like that. That's equal to 35,300. Okay, so we're not going to put our answers that the diagonal of the flag is 35,300. It's not 353 meters long. The flag, it's not, you know, a boat or anything like that. So what we need to do, if that is what is x squared, we need to square root that to find out what x is. So x is equal to, and we want to write this down in our working, it's the square root of 35,300. So again, we're going to take our calculator. If you've got one of these Casio calculators, brilliant, just press the square root button and hit this little answer key down at the bottom, otherwise you have to type the number in. So the square root of 30,500 is 10 lots of the square root of 353, but that's no use to us. So this little button here, SD, for switching between what that is called a surd and a decimal. Okay, I'm going to want to round that a little bit, but I need to write down a bit. So 187.88 and then some stuff. So that is 187.88, and I'm just going to put a dot to show that that's what. Let me check. That was 187.88. Let's round that perhaps to, my numbers here are 170 and 80. If the question doesn't tell me what to round it to, I'm just going to make it something similar to that. So I'm going to go to a whole number. 100 and 88 centimetres. Little check on the answer, does it make sense? The hypotenuse, the diagonal of a right angle triangle will always be the biggest side. So if I did something wrong and that said it was less than 170, that's when I'd look back at my work and try and find out where the problem has came from. Okay, let's look at one more example. A warning sign here is in the shape of an isosceles triangle, and it asks us to work out the height of the side. So in order to use Pythagoras, or to use any of the trigonometry we know at National 4 level, we need to have a right angle triangle. I'm going to make that right angle triangle by going down the middle there, and I make two right angle triangles. I'm going to use this one on the left. Important words from the question. It's an isosceles triangle, so that means that this part here and this part here are the same. So let me draw my little triangle that I'm going to use for Pythagoras. "65" is something I know there. The height is what I'm trying to find, so let's call that the letter H. This dimension here, I need to recognise that that and that are equal. They're both equal to half of 70, so they are both equal to 35, and that's in centimetres. Okay, now I'm trying to find this H squared, but it's not the hypotenuse, it's one of the shorter sides, so I'm having to take away. So I'm going to do 65 squared, take away 35 squared. Always the bigger one, take away the smaller one. So 65 squared button, take away 35 squared button is equal to 3,000. Again, the height is not 3,000 centimetres, it's the square root of 3,000. Square root sine 3,000. Go back to my calculator. Square root, and again, if I've got the Casio, I'm going to press answer, but if I've not, I would just type in 3,000. It's not going to kill me. I need to press this button if I get an answer that looks like another square root. So that will give me 54.77 and then some other stuff. .77. As soon as I wrote it down, I'm going to check my calculator again. That was definitely what it said. 54.77. I'm just going to round that to a similar degree of accuracy to the question, so the nearest centimetre is probably best. 54.77 is going to round to 55 centimetres. And again, my little does this answer make sense check is just to make sure that the 55 is smaller than your 65, smaller than your hypotenuse. And if it is, the answer is reasonable. Okay, so we'll stop there.